Alright, section 8.1 here. Do this video. I'll make two videos of this because it's kind of lengthy. And what you need to do is watch both videos, fill out the notes as you're watching them, and then we'll do homework together. Section 8.1 is just all of your integration rules put together and figuring out which method to use for each integration. So some of you might know how to do these already, but I'm going to go through each one of them and show you the method that's used. Alright, so basically fitting integrands to basic rules. And if you look at the last page of your notes, there's different techniques that you can use. There's 7 techniques, so you can go through each one of those. Alright, so for the first one, you have to decide what it's going to be. Now, most of you probably use U substitution. I'm just going to show you that U substitution doesn't work for this first one and why, and then I'm not. So if I let u equal x squared plus 9 and I go du equals 2x dx, du over 2 equals x dx, and again this part, this x dx needs to match the numerator. In this case it doesn't, there's an extra x, so u substitution isn't going to work. So what you need to recognize is this is going to be a trig integral. Alright, so the first thing we're going to do is bring the 4 out in the numerator, that constant, and I have 1 over x squared plus 9 dx. Yeah, and you might want to go back and review arc sine and arc cosine and arc tangent, those rules. Alright, so for this one, if you remember when we do integrals of trig, we're going to let u equal the square root of x squared, which is x. A is going to be equal to 3, and then when we do du of x, I get 1 dx, and that's going to match the numerator. So I can rewrite this as 4 integrate of 1 over, let's see what this can be, u squared plus a squared, and then du. And you have to recognize that that's arctangent. And the rule for arctangent is going to be, we have that 4 that's out in front, and the rule is 1 over a arctangent of u over a plus c. That's the actual rule. Now just plug in the numbers. I'll come over here and do that. So a is 3, so it's going to be 4/3 arctangent of u over a plus c. Alright, and there's the first one. And again, I would think that some of you are going to try to use substitution, but that does not work. Alright, now the next one is very similar, but now hopefully you can see that the use substitution is going to work. Because we have an x squared in the denominator, when I take the derivative of that u, it'll be a 2x. So I'm going to let u equal x squared plus 9. Du is equal to 2x dx. Now it almost matches the numerator, but this is a 4x dx up here in the numerator, and we need it to be a 2x dx. So I'm going to factor out a 2 out of the top. It's a constant, I can bring a 2 out, and rewrite the integral as 2x over x squared plus 9 dx. And now I can rewrite everything in terms of u. So I'm going to get 2, integrate. The 2x dx is now du. So I'll put 1 du. And the denominator becomes just u. And we have a 1 over u. And the integral for 1 over u, it's 2 ln absolute value of u, which is x squared plus 9. And then don't forget your plus c. Alright, so again, when these are going to be put on the quiz and for homework, you're just going to have to try a couple different techniques to see which one's going to fit the integral. Alright, this next one, again, you can see the progression. It was a 4 in the numerator, then it was a 4x in the numerator, now it's a 4x squared. Alright, so for this one, and I'll write this little rule out. When the degree of the numerator is greater than or equal to the degree of the denominator, degree of denominator, you need to do long division and rewrite that fraction. All right, so we're going to do long division for this one. And again, if you did use substitution and you tried it, you'd make u equal the denominator x squared plus 9. And then when you did the derivative of that, you'd get an x, and the numerator is an x squared. So you're going to have to do long division. I'm not going to show you the use substitution doesn't work. Just trust me. All right, so outside is going to be x squared plus 9. And then inside, we're going to have a 4x squared plus a 0x plus 0. Just take care, put the zeros in to be placeholders. And then an x squared to become a 4x squared is going to be a 4. So I'll put that here. And then just multiply. So 4 times x squared is 4x squared. 4 times 9 is 36. I'm going to put that over here. And now when I do my subtraction, don't forget to change the signs. That's going to cancel out a 0x, and that's nothing here. It's going to be 0, and then I have minus 36. So you can rewrite this fraction as 4 minus the remainder, which is 3, over the divisor, which is x squared plus 9. So we're going to rewrite the integral and then integrate those parts. So we're going to integrate 4 minus 3 over x squared plus 9 dx. And then we're just going to break those two apart. So integrate 4 dx minus the integral, oh, that's 36. I'm glad I caught that. Minus 36 over x squared plus 9 dx. Alright, so the integral of the first one's easy, that's the 4x, and for the second one, you're either going to have to try use substitution, but again, this is a trig one. So I'm going to bring the 36 out in front, leave the integrals 1 over x squared plus 9 dx, and that's going to be arctangent, because u is equal to x squared, du is going to be 2x. Alright, pause. Okay. I have to remember when I do u, it's the square root of that. That should be x. I noticed that when I went to go du and I had an extra x there. So u is going to be equal to x. A is equal to the square root of the 9, which is a 3. This du is going to be 1 dx. Alright, so everything's going to match up now. So now I got a 4x minus 36 times the integral of that is going to be 1 over a arc tangent of u over a, x over a plus c. And I guess we could simplify that a little bit more with a 4x minus a 12 arc tangent x over 3 plus c. Okay, I'm probably going to do 2 more and then I'll create a new video. It's getting kind of long. Alright, so this next one. Okay, so this next one, again, you can try use substitution. You can try a couple different things. You can sit there and let u equal 4 minus x squared. And when you do du, it's not going to match the numerator. You can also look at this and say, oh, this could be possibly be arc sine. And for arc sine, you'd go u is equal to the square root of x squared, which is just going to be an x, and du is equal to 1 dx, and then a would be equal to 2. But again, if you do use substitution for this, it's not going to match up in the numerator. So neither of those work, these methods work at this point. So the next one we're going to try, and again, I'm just going to tell you what to do, is you're going to separate these. So you're going to write 2 separate integrals of x over the square root of 4 minus x squared, and then plus integrate 3 over the square root of 4 minus x squared with a dx and a dx. And this first part here is going to be the u substitution part, and this second part here is going to be arc sine. Alright, so again, when I do this u substitution for the first part, I make u equal 4 minus x squared, then du is going to be equal to negative 2x dx, and I'll bring the 2 out, so negative du over 2 equals x dx. And for this second part, well, let me do the first part of this integration. So I have a negative 1/2 out in front from the u substitution. My x dx is going to become the du, so this is 1. I'll put the du there. You can put the du in the numerator, it doesn't matter. And then this is going to be the square root of u. And we'll integrate that in a second. For this next one, I'll bring the 3 out front. I have 1 over, and again, this is going to be 4 minus x squared, which is an a squared minus a u squared, the square root. So that's going to be the rule for arc sine. Again, make sure you go back and look at your rules for that with the dx. So I'm going to do the u substitution, or excuse me, the u and the a for that part. So, alright, so negative 1/2. Alright, this part here, that's really 1 over u to the 1/2, which I'm going to rewrite as u to the negative 1/2. So I'm just going to keep rewriting this. So u to the negative 1/2 du plus 3 integrate 1 over the square root of 4 minus x squared dx. Alright, and last but not least, I think I'm going to actually integrate here. So I'm going to get a negative 1/2. The u to the negative 1/2 becomes u to the negative 1/2, and now when I integrate that, I'm going to add 1 to that exponent, so it's going to be the u, which in this case is 4 minus x squared. Adding 2 over 2 to negative 1/2 is going to make that a positive half. Divided by 1/2, multiplied by 2, so there's going to be another multiply by 2 out in front of that. And then plus 3, and the integral for this is going to be, is that a 3 or a 1? That should be 3. Okay, 3, and then arc sine of u over a, and u is x over 2 plus c. Alright, so now I can simplify this. I should get a negative quantity 4 minus x squared to the positive 1/2 plus 3 arc sine of x over 2 plus c, and I guess I could do negative square root of 4 minus x squared plus, whoops, the plus should be on the outside, plus 3 arc sine of x over 2 plus c. That's pretty involved. But again, we did a couple during the year. You might not remember, but we did. Alright, I'm going to stop there for this video, and then I'll create a new one for the next stuff.